Good evening, sir. Sir in class? Testing, testing. Anybody hearing me?
Yeah, hearing you.
Okay, that's all very good.
All right, good evening, guys. Um, I'm having a challenge because, oh man, something is. Give me half a second. I'm having an issue. Hold on 1 minute, please, guys. All right, so I um I had a split screen open and a video was playing in the background, and for the life of me, I could not find what was playing. I know I hear something, couldn't find it, and it was really annoying me. The system shut down and came back up, and long and short is that I eventually found it. All right. So God, the document gone. So I started something with you. Um, some binomial stuff with you last time around, and you were having a difficulty. Any of you were able to go through what it is that we looked at the last time?
I was looking at it, the combination notation.
Yeah.
Yeah, I was looking at it, sir. Is it it's not that hard. The only issue that I have is the exclusion of like Say for example, if you have 5 objects, like 1, 5, 4, 3, 2, 1, and it's an over. You have the denominator. Say 3, 3. Say that starts from 3 times 2 times 1. Yeah. All right. So is it the same as the flipping the coin where you would basically exclude what is not necessary and continue the multiplication? So for example, for choices that you have 1, 2, 3, you would exclude the first 2 and so on, and then 3 you exclude 3. Because it seems similar to what Venik had done to get the no. It would have been the same. Just I realized something.
All right, put the same. I'm looking at the probability of us winning sports day. Mikey is down for, it's kind of a joke still, but I'm just gonna run with it. So if you want to laugh, you can laugh. Mikey is down for the 100 meters, 200 meters, 400 meters. And there's like 800 meters that Maggie was supposed to be down for, along with a relay. So 5 events, 100, 200, 400, 800, and a relay. You did not turn up for the 800 meters. You have no plans to turn up for the 800 meters. What's the probability of you giving points to the team?
0. That because
0.
But of course.
I tell you, but I'm just saying to you, the probability of you adding points to in 800 meters will be 0 because you're not running that event. But the probability of you giving points in the 100, 200, 400 and the relays is anything between 0 and 1. Well, anything greater than 0 but less than 1. Because the mere fact that you turn up for the finals, you'll get a point. I don't know if you're following what I'm saying. The probability of you winning will be 1.
Yeah.
If you come dead last, you won't get 0. If you come dead last, you won't get 0. The only time you'll get 0 is if you don't run the race. You follow what I'm saying?
Yes,
Yes, sir.
Yeah, man. So that answers, Mikey. I don't think what you're asking about is with regards to this question that is being projected. I think your question is in regards to this one here, when there was no 3.
Yeah.
True or false? Yes, no?
True. Yeah, that's it. I said it would have, yeah.
Yeah. So right. So that one is I give you. It means that you just never agree. The probability today, not too long ago, when I'm waiting on this system to come up and it shut down and I had to restart and I had to log on in the other system for you guys to know that I'm around. I'm there biding time and I went on TikTok and I saw a video where this guy claims that he's on Malines Road, clearly on a motorbike, and he was just going through the traffic, and I was like, how irresponsible, how reckless, because there's a possibility or a probability of him hitting somebody's side view mirror, of 2 vehicles end up crushing him because one may decide to overtake another and not recognize that he's dilly-dallying through because he was really dilly-dallying through. The point
The
is,
TikTok video, sir.
yeah. You saw it?
Yes, sir. I saw it.
And you know, things said the boy crazy.
Yeah, at some point I thought something was gonna happen.
I thought
Because
something
him
was
like
gonna
going
happen.
through, moving.
Because normally, I wait to the first 5 seconds of the video and decide whether or not it has any interest to me. And after the first 5 seconds, I will just scroll. I don't have time. In as much as so the videos maybe a minute long, I don't have time. If it's 5 seconds, grab me the 5 seconds, I'm scrolling.
Yeah.
But when I see this,
that's amazing.
Yeah, man. When I see this guy's like, oh crap, what is gonna happen now? And I'm waiting and I watch what the video and I watch what the video is like, he's crazy. But so what is gonna happen now is I want us to pay some a bit of attention, and this is all that I want to focus on. You know what? Let me just say something, because I said something to Mrs. Hall Francis yesterday, and she quite frankly agrees with me. Students, I have covered quite a bit of information already. If you were given an exam now with the information covered, I know you would be in a position to pass the exam. I'm not teaching you guys the course for anybody to get a resit or a redo. That's not the aim of me teaching. I know everybody won't get an A, but I know everybody can pass. Everything that I've gone through already, make sure that you are revising, you're going over it on your own. Make sure. All right, not saying anything more on that.
So, I can add to what you just said.
Go ahead.
Based on my experience with Miss Hall Francis and what she had stated in pre-calculus, once we follow what you are or what she or you say, we have a problem in the exam. And I am proving that. So
absolutely,
I will take the word for it.
And I have done 2 courses with you already, and I have another course to do with you. I've done 2 courses with Benika already. This is the 3rd course, right, Benika? This is the 3rd course, no? Or so, yeah.
Yes, sir.
Right, this is the 3rd course. I have one more course to do with you. Listen, and what I said for the chemistry, Benika, was I far off from it?
No, sir.
Okay, listen. When you go through the something, they're not going to be given any formulas on the paper. When you're supposed to know the formulas out of my head. Go through. If the exam were tomorrow, hold on. Sorry. The exam is scheduled for tomorrow. You guys should pass the exam. Let's go. I really want to spend what is this? Sorry. I want to spend a few minutes developing what is happening here. And what is happening is my binomial. I want you to be able to recognize what is happening here. In here, I have 2 terms, A and B. So what if they have 3 terms? It could work. There's something named
binomial. So it could work. Binomial or 2.
Binomial is 2. All right, so you follow the strips. So binomial is 2. Let me go through the let me go through the I see my okay. So let me go through the formulation with you again. The combination notation is how many ways I can combine the stuff. Order is not of importance here, but the permutation order is important. So a plus b to the n is going to be n to 0. You always end up with one more than the term up here. So if I give you a plus b to the 3rd, you're going to end up with 4 powers, 4 coefficients. you're going to end up with 4 coefficients. Why do you end up with 4 coefficients? Because of the n to the 0. N through 0 is always 1. N through 0 is always 1. So you're going to end up with an extra term. What am I saying? It is n through 0, this a to the n power b to the 0. Because as this one ascends, this one descends. As this one descends, this one ascends. As this one descends, this one ascends. So watch me. This is going to be a to the n. B to the 0. I didn't have to write the b to the 0 because anything raised to the power 0 is 1. Right? But this one is going to descend. This one has to descend before the other one ascends. I must put money in the bank before I can draw it. I must put money in the bank before I can draw it. So one must descend before the other one ascend. So A must go down so that B can take up what A took up, what A give off. So what is happening is this is A to the n, it now becomes A to the n minus 1. See here, so A to the n minus 1. And because I'm taking off 1 from here, so B is going to take it up. See here, B take it up. The R value, n choose R, the R value and this value must be the same. And the sum of these two must be the overall sum of the binomial. This one is losing 1 more, so it's going to be A to the n minus 2. And B is going to take up the 2. So any amount that A gives up, B take it up. See here, A give up 3, B take it up. See, A give up n. N minus n is 0, but B take it up. All right? So can you see this formulation a little better now? Yes, no, maybe so?
Yes, sir. But my question, it always starts with n through C.
Yes, it's true 0. When you do the binomial, it's always n through 0. Always.
But with the Pascal, it would start at 1.
And that's what n through 0 is. N through 0 is 1.
Oh, okay.
So put on your calculator 9 through 0, 5 through 0, 8 through 0, 100 through 0, and what you get. All of you.
1.
1. Anything through 0 is 1. Anything through 0 is always equals to 1. Are you following me?
Yes, sir.
Yes, sir.
Yeah, man. Is it Asia that left?
Yes, sir.
Yeah, not seeing her.
Right. So anything through 0 is 1. So that's how you end up getting your palindrome. 1331, 14641, 1510, 1051, 1615, 2015, 61. That's how you end up getting your palindrome because you always start with the number through 0. Any number through 0 is always going to be 1. Any number through 0 is always going to be 1. No, say yes or no, please. I need to know that you're following me.
Yes, sir.
Yes, sir.
So the n would be the n, the C, and the 0 here would be R.
Yes.
The lower number below
Yes.
this would be R. Okay.
Yes. Yes. All right. Are you fully with me? Are you fully there? Can we move?
Yes, sir.
All right. I want to show you something based on something that was asked. I want to show you something, but I will show you that after I go through this. Just so that you can see what is happening. All right. Okay, today. All right. Okay, let me tell you something out here. No. So the question says, the probability that it will rain on a given day in May is 0.3. The probability that it's going to rain in May is 0.3. That's the probability of it raining. Then it is asking you to calculate the probability in a given week in May that it will rain on exactly 2 days. That it will rain exactly in 2 days. So the probability that it will rain on any given day in May is 0.3. We need to calculate the probability that is going to rain exactly 2 days. All right. How do you think we are going to be able to evaluate this? Let me hear your thought before I do it. You know?
Sorry, man, I think look at it. Hold on.
All right.
So sorry,
Yeah, go ahead, Papa.
Sir,
Yeah?
I was asking if I could go back up to the top section. Because I kind of not
Sure.
following, but probably try to remember.
All right. Let me go through this. Let me go through it first, and then you'll see what I'm talking about. Let me go through the question. If I speak about binomial distribution, bi means
Oh,
if the probability of something occurring, if the probability that it will rain on a given day in May is 0.3, what is the probability of it not raining?
the probability of it not raining.
Mm-hmm.
It not raining will be 0.
Think about it a little longer. I want all of you to think about it. Remember.
Sorry, you can
Two?
No.
One?
sir,
Oh,
can you
one.
repeat the question?
One.
1.
Now we're saying binomial is 2, so is it 1?
Okay, so binomial is 2. All right, I soon come to you, Paz. Binomial is 2, yes. But if I'm tossing a coin,
1 out of 2, sir?
that would be 1 out of 2 to toss a coin. But if I say to you that the probability of it raining is going to be 0.3 on any given day in May, what is the probability of it not raining? Think about it. I can't tell you, but I want you to think about it. If I say to you that the probability of me passing this exam is 0.5, what is the probability of me not passing?
1.
0.1.
0.5? Half and half?
Okay, now we're getting closer. So use that argument, Venica, and answer this one. If the probability of it raining is 0.3, what is the probability of it not raining?
0.3.
0.3.
All right, Venica, listen to what it is that you said just now. If the probability of me passing an exam is 0.5, that means the probability of me failing the exam is also
0.5.
all right. If the probability of me passing an exam is 0.3, what is the probability of me?
Oh, you got added 0.7?
Duh.
Oh, so it has to
Because
be
the sum of the
1.
probabilities
Equal 1.
equals
1.
1.
Lord God.
Remember, it's binomial, and you have 2 things. So if the probability of me passing an exam is 50%, that means the probability of me failing has to be 50%.
Oh.
If the probability of me passing an exam is 0.3, it means that the probability of me failing the exam has to be 0.7. So I have a greater, one of the things I could have said to you, 0.3 is the same thing as 30%. Because when I multiply 0.3 by 100%, I get 30. So the probability of me passing the exam is 30%. What is the probability of me failing? Has to be 70%. Talk truth.
Yes, sir. So, I realized you keep on saying probability.
Yes.
Some of the probability have to
is one. So that's why I say I could come tell you, but I don't want to come tell you. I want you to think about what it is that I'm asking you. All right. So let me go back to the question now. The probability that it will rain on a given day in May is 0.3. What is the probability that it's not going to rain?
0.7.
0.7. Very good. 0.7. No, there is something else in the question. What other information can I get out of the question? There's a word that makes a difference. I can use that word.
The week?
Very good. And how many days in a week?
7.
No, that we get it. So the point is, I am using the information given in a worded form, and I'm extracting information from it, right? And I'm extracting information from it. So one of the things I'm going to say to you is, my N is going to be 7. Remember talking about binomial distribution, My N is going to be 7. Sir, why 7? Because it's in a given week. Yes or no?
Yes, sir.
Yeah.
And you know that. So we talk about. Let me go up here so you can see the question while I'm doing this up. So it says the probability of it raining on any given day in May is 0.3. Any given day. We need to calculate the probability that in a given week, and in a week I have 7 days, in a given week, in May, it will rain on exactly 2 days. Look, I know that in a week I have 7 days. I have 7 days. I know the probability of it occurring is 0.3. That means the probability of it not occurring is going to be 0.7. So therefore, the probability of it occurring A is going to be 0.3 plus B is going to be 0.7. And I know N is going to be 7. Talk truth. Because we're talking about 7 days. Yes or no?
Yes, sir.
No, what would be my R?
Your R would be the beginning 0.
No. Before I go that, before I go the beginning 0.
Oh,
what
7,
is
7.
No, my N is 7 because I have 7 days in a week. I want to find out what do I need to find? Look at the question. What do I need to find?
Oh, exactly 2 days.
So my R is going to be
2.
My R is going to be 2. So I know I have a maximum of 7 days, but I want to see what is going to happen with this binomial now in 2 days. So what it is that I'm going to be doing is to say, I know my N is equals to 7. I know my probability is at X equals 2. So it's going to be 7 choose 2. And this is going to be my 0.3 is going to be to the second power. Why? Because that is the probability. Remember, the probability of it raining is 0.3. Talk truth.
Yes, sir.
Yes, sir.
So the probability of it raining in exactly 2 days has to be 0.3 to the second power, don't?
Yeah.
Right.
Good. And then the probability of it not raining is 0.7. That means the 5 days will be the days that it's not going to be raining. True or false?
True.
So that's why the 0.7 is going to be raised to the 7 minus 2, which is 5. Make sense?
Plenty.
Let us relate this now back to what it is that we're doing here, because it's the same thing. So I'm saying to you, there's a slight difference, however. you know how it is that I'm writing. Mark, you, I can anyway, it makes based on how I'm explaining now, it makes a whole lot more sense than ever. Remember, I said to you that when you're looking at your binomial pause, you're not following. When you're not following, you go silent. A plus B to the n. And when n through 0 times A to the n, this term plus this term should give me my overall term. And the last power and this and are supposed to be the same. So you see this one and this one, this two and this two. However, look at my question. I know I have a maximum. My n is equal to 7. Why, sir? Because it says a week. It says, what is the probability that in a given week, it will rain on exactly 2 days? On exactly 2 days. So it means that the probability of it raining is 0.3. So it raining exactly 2 days, I'm going to say 0.3 squares. The probability of it not raining is going to be 0.7. That is going to be raised to the 5th power. So what I want you to do for me, check to see if I got it right. 7 choose 2, 0.3 to the 2nd power times 0.3 to the 2nd power times 0.7 to the 5th power, and see if you get there 0.318 for me. I'm stepping away for 2 seconds. Work on that for me, please, and let me know if you get the same answer. And come back to me and let me know if you're following. Paz, I need to hear from you.
Yes, sir, I got that.
It's 21? How you do that?
Yeah, how you get it 21?
A 49 me get.
Yeah, cause
49?
Yeah, cause 7 to the 2nd power. I don't know how 21 for me.
Hmm?
I don't know how you get that. Or how you get 21.
How you input it in the calculator, Venica?
I put 7 the little I call it less than sign or upside down. 2. We get 49. And the 0.7 to the 5th. Where am I getting now?
Where you
But
put in
when I get that 21 something they do.
No, not it. You see no Paz?
You're not getting the 21 at the
You're not
front.
getting it. You're not getting the 21?
7 choose 2. It's
7
not
choose
49.
7 choose 2. How do I do 7 choose 2 on my calculator again now? I have a
so you
different
put 7 and then you use the upper sign and
And
then
2.
2.
Normally you're going to do 7 and then
Mm-hmm.
you're going to put C. Yeah, look at the calculator, see NPR, NCR and NPR.
yeah, mine I want 2nd
I
power.
don't see that sign.
NPR.
NPR or NCR, yeah.
I see that. Because when I do it for the other
We get 42. Hold on, let me try it the other way.
NPR.
Hold on a minute, please.
Let me get 0. So I'll go on.
Let me try that one here.
NPR. Sure, let me get 42.
No, sir.
Benita, I want me to.
Because when Mr. Alright, if Mr. 1 to the 0, me get back 1. So me do 1 the upside down something to the 0, me get 1. 1 choose 0, me use the little upside down V and get the 1. I don't know. And when me do 7 to it.
Sorry, hold on, Venica, because I am there talking to you, Venica, and I'm muted.
Sir, NCR you use?
Yes.
Oh yeah, man, 21. Cause
But I don't see that on my calculator.
Okay, Venica, all right, Mikey, turn your camera on and put it to the calculator.
So, sir, why when we do the 7 with the upside down V to the 0,
No.
give me 1.
Yeah, man, yeah, because 7 to the 1 is 7 to the 0 is 1, but that's not what you're supposed to be using.
remember, so
So-
my calculator is
Special.
Michael, clean off your
Blurry.
camera. Nah, see
It
nothing.
blurry.
Mikey, very blurry.
for
Come
real?
back a little. Yeah, man, very, very blurry. Can't see a thing.
Hold on, I'm gonna clean it off.
All right, seen it now.
Okay.
Michael, we do you see your face.
No, Venica is in a Mikey, we're not seeing the calculator. We're not seeing the calculator. All right. Show me the NCR now. Show Venica. Oh, but I don't know why you go of all the places where you go buy Texas calculator. You want a big stuff in your head.
Mine is a second function, but it's second function and it's
No, Michael, sorry.
We now see a thing. It's all right. You turn off your own, Mikey. Pause. Make something bogus. Bogus. Pause. Let me see your calculator. And you can't feel me now, you know, because me I tell
this
Mikey
one
second.
the Casio. I don't know if you've seen it.
No, how are you there?
yeah, man, in the second.
You see it?
Oh,
me see.
me not see him.
The video is on. So I don't know.
All right. Yeah, I seen it now. Come on, pause. Let me see something.
I know. Why?
All right.
Is the Casio you have, Venica?
All right.
No, you seen mine?
I'm seeing you, but not the calculator. All right. I seen pass one now. Just look at pass one. Pass. Hold the calculator up a little bit more. All right.
That's
Stop.
good.
Oh, Rockstone. Go back a little bit, pass. Where's the NPR? Where's the NCR, pass? Which number is that? Look at me which number the NCR is that. I'm coming. I'm waiting for something. Oh, but I should have a calculator like that.
Let me do.
Would it like?
You see it?
Why you can't see pause?
The video poor. The light behind me.
Why is Michael missing? Why may I see a picture of Michael?
Wendy, can you see it now?
No, sir, not seeing anything.
Which calculator you have?
One that named DELI, Delhi.
Okay. That explains it. Who is that?
Michael game calculator.
No pass, you don't play fair. That's not a good. That's no pass. No. That's a blow below the knee. No.
You see the calculator, gentle people.
All right. Yes, I'm seeing the calculator. All right, hold it up a little bit. Oh, Jesus. Oh, How can I delete that? Yeah, buy food out there. So roll it up a little bit more. A little bit more. Higher, a little higher. Whoa. All right, it's not on the raised key, so more than likely it's on the submerged key. Look, but if I go calculator because it says calculate on it, and you have the integration sign, and you can do integral on it, so it looks like it's not about. Look over the multiplication sign when you can't tell what to see. Look over the multiplication.
NPR.
Huh?
NPR.
All right, look over the division sign. Tell me what to see now.
NCR.
Oh, that's what I'm asking you to look for. So you're going to use the NCR. So what you're going to press now is 7, then NCR, then 2. But what you're going to do in order to get the NCR, you have to press shift because your one is on the submerged key, not the raised key. So press 7, shift, then NCR, then 2, and then you can get it. Tell me if you see it now. If you get the 21.
So there's some of your eyes. Oh, sorry. Yes, I'm seeing it.
Okay, good. All right. Let me, this is pre-calculus, and I'm sure you had to use this for pre-calculus.
That one, sir. Remember my
Well, I had a Casio at that time, but I got broke and I had to buy the cheaper one now. I can't find it.
Oh my Lord. Then you got
0.31777.
Yeah.
Come on,
All right. Let me let me
Because I didn't never thought to work it out.
let me try something here because
Okay.
um
All right.
all right, you're supposed to be seeing a blank screen coming now. Let me
Yeah, man, the blank screen is up.
Yes, sir, I see it.
So I really can't have a question yet because I need to show you some little things that are happening with this first one. I'll take the time and show you so at least you have it. So that when it comes on today, you see it and you know what it is. So what I'm trying to do is for you to make connections with prior learning. I'm trying for you to make some connections. So I'm trying to get my tablet up. All right. So now, so n is equal to 7. Are you seeing that?
Yes, sir.
N is equal to 7. The probability of it occurring is equal to 0.3. And for use Q to be the probability of it not occurring is going to be equal to 0.7. So what I'm going to have is 7 choose 2. Why 2? Because I am trying to find the probability of it occurring in what it said? Exactly 2 days. Exactly 2 days. All right, so 7 choose 2, then it's going to be 0.3 raised to the second power, because this is the probability of it occurring, and this is in the number of days. And then the probability of it not occurring is going to be 0.7, not occurring. And that is going to be to the 5th power. Why? Because the powers, this power plus this power, 2 plus 5 must be equal to 7, the overall power. So that's why I was going through the whole business of the NCR to show you how it relates again. So even if you never know, and then also the sum of the probability here must be equals to 1. 0.3 plus 0.7 is equals to 1. The sum of the probability. All right, now, so let me just rewrite it so that you can see it properly now. 7 choose 2 times 0.3 raised to the second power times 0.7 raised to the fifth power. Now, let me just show you how the 7 choose 2 work out manually. 7 choose 2 is the same thing as NCR is 7 factorial over 2 factorial, 5 factorial. NCR is equals to n factorial over n minus r factorial. Oh. N minus r factorial, r factorial. So n choose r is equal to n factorial over n minus r factorial times r factorial. All right? Now, 7 choose 2. Hold on, please. Seven factorial is going to be the same thing as, this is going to be 7 factorial over 7 minus 2 factorial, 2 factorial. 7 factorial, which is the same thing as 7 factorial over 5 factorial, 2 factorial. 7 factorial is 7 times, I don't know what is wrong with tonight. 7 times, I'm sure Mrs. All Francis did this. 7 times 6 times 5
yes, sir.
times 4 times 3 times 2 times 1. And
Over
5 factorial is 5 times 4 times 3 times 2 times 1. And 2 factorial is 2 times 1. 5 times 4 times 3 times 2 times 1, cancel 5 times 4 times 3
Cancel all
times 2
those,
times 1.
yeah.
And 2 times 1 is going to that, and it's going to that 3 times. So 7 times 3 is 21. So I did my one manually and got 21. On the calculator, when I put it in, you're supposed to get 21. So it's going to be 21 times, what is 0.3 to the second power?
0.9.
0.09.
Yep, 0.09.
And 0.7 to the 0.7 to the fifth power is
0.1681.
168. All right, I get 107. All right, good. Same difference. When I multiply that now by 0.09 and times 21, what do you get?
0.317.
All right. 0.317. And that's what I'm saying to you. So the probability is going to be 0.317. And matter of fact, it's 0.76, so it's going to be 318. I'm going to add 1 to it because it's 0.76. You agree with me if I add 8? Venika gone? Okay, Venika not there? No.
Yeah,
Yes.
it will be 0.8 because it follows 7 and some other.
Right. Right. All right. So are you seeing this now? Are you agreeing with this?
Yes, sir.
All right.
Yeah, hold
Let
on
us,
1 second.
no problem.
You see where you work out the 21? No, man, go back there. No, back to the yeah, right here, work out 21. All right, so the 5 factorial would cancel out from 5.
5. Go right down, yes.
And then the 2 would divide the 6.
The 6 into 3.
Ah.
And 3 times 7 is 21. But you see, you don't have to do it manually, because we all have calculators. So we just run it and just put it in the calculator. 7 through 3, boom, 21.
That's true.
Right. All right. So we're going to get this 0.31 now. So if you remember what the question is saying. Remember what the question was saying. What we just did a while ago was in exactly 2 days. This one here now, the second part of the question says at least 2 days. So when it says at least 2 days, what is it saying? At least 2 days. At least 2 days. What do you think it is saying? Okay.
No less than the 2 days.
Let me show you something. So this is a probability of it being exactly 2. At least 2 days. The probability for at least 2 days. How do I write at least 2 days?
Less than
X,
2, but greater than X.
All right. So let me answer the question another way, because let me answer the question this way. Suppose I say to you that I have at least $100 in my pocket. Interpret how much money I have for me, please.
You have more than 100.
Greater than 100.
100
I have at least
$100 or
$100.
less.
Yeah.
I have at least $100 in my pocket.
Oh, it's
So more
equal.
than 0, but less than
Equal.
100.
Equal or less than 100.
I mean, not tell you this one tonight, just like I'm never tell you the one with the 0.7. Work with me. Work with me. Let me create a scenario. I am going to the supermarket. I know that with me, I have $20,000. I am picking up items, I'm picking up items, I'm picking up items. And I say, you know what? I can pick up the items because I have at least $20,000 with me. I have at least $20,000. If I have at least $20,000, what's the sum total that I could pay to the cashier? I have at least $20,000.
19,999.
20.
Actually, 20.
20,000, that are the most I can spend. So it's gonna be
It's more than 0, less or equal to 20,000.
yeah, that will
Wait,
be. So it will be equal to 20, but less.
Because the way how I'm thinking about it now, I'm thinking about it could be 20,000 or more.
Right.
All right, so like if you explain it to somebody like how much money you have, so you say you have at least 20,000. It could be a case where you have like you have like the 50,000, but you don't have anything less than the 20. So you know, so you have at least 20,000, but you know it's more than that. If you get what I'm saying.
Very good. So I know that I have more than 20,000. So I have at least 20,000. That's the minimum I know I have. I have at least 20,000. So I can have 20,000 or I can have more than 20,000.
That's true.
If Venica, the example that you gave, it means that I have no more than 20,000.
Yeah, or if it is the most you have is 20,000, but it's how we talk.
It's how we talk, right? So this is why I asked the question, because I want you, if I come and tell you, you're not going to be able to think about it on your own. But if I say to you, think about it and just have a conversation about it, and I find examples and give to you, you'll have a greater appreciation of it. So at least, let's say, at least 2 days. So at least 2 days is going to be what?
Equal or greater than
2 days or more.
Very good. So my X is going to be greater than, oh crap. My X is going to be greater than or equal to 2 days.
You know, that are the exact thing me did I think, but me never did I.
Say it, man. Say it.
No, as in, if they asked me for write it, that's how I would have wrote it. But it's like, I don't know, now say it, like how Paz could have said in my first part of the class. See that no. But to write it, I could have wrote it like that. That's exactly what I wrote down.
Good. So let me ask you the question now. Let me ask you the question. So, we know that it's going to be greater than or equal to 2. So that means the probability of it occurring is 2 or more, don't?
Yes, sir.
Good.
Yeah.
What is the probability of it not occurring? If the probability of it occurring is 2 or more, based on the probability that we just wrote a while ago, x is greater than or equal to 2. What is the probability of it not occurring?
2 or less.
Okay, less than 2.
Okay.
Not 2 or less, but less than 2. So if I say to you, the probability of it being greater than or equal to 2 is going to be equal to 1 minus the probability of it less than 2. This is not occurring.
So that's mutually exclusive.
Okay, so it's not occurring. It's not occurring. So we are saying that we're looking at the probability of it occurring for at least 2 days. So it means that it's going to be raining 2 days or more. No. That is the probability. So it can rain 2 days, it can rain 3 days, it can rain 4, it can rain 5, it can rain 6, it can rain 7, don't?
Yes, sir.
Good. What is the probability of it not raining?
So that's mutually exclusive based on the statement.
What is the probability of it not occurring? Tell me which probability not. How many days do we have?
7.
7 days. It can occur 2 days, 3 days, 4 days, 5 days, 6 days, 7 days. Which days it cannot occur? Give me the values that are less than 2.
1 day or 0 or none.
Very good. 1 day or 0 days. 0 day or 1 day. Are you seeing what I'm saying right there?
Yes, sir.
Yes,
So
sir.
if we are saying that the probability of it occurring is either 2 or more, the probability of it not occurring, it has to be less than 2.
Less than
Less
2.
than 2 is
Yeah.
going to be 0 and 1. It
Yeah.
can't be -1 because we know so we not talk about them days. That not exist. -1 does not exist. But it cannot rain at all, or it can rain for 1 day, or it can rain for 2 days up to 7 days. You get what I'm saying? So
Yes, sir.
So what we need to do now is to find out 1 minus the probability of it not raining. The probability of it not raining. Also, the probability of it raining just 1 day. So this we know that is the probability of it. The sum of the probabilities will always be equals to 1. So the probability of it not occurring plus the probability of it occurring for 1 day, and then we get that sum, and then we subtract it from 1, and we should get the probability of it raining at least 2 days. So tell me now, based on what we just did up top, the probability of it not raining is what? Based on what we did here, the probability of it not raining, what is it? Look at what I just highlighted and tell me. Come on, guys. Come on, man. Come on, man. Use the same something up here, son.
So it'd be
1 7
1C.
No, man, it will be 7 through 0. Remember, you know, the probability of it occurring up here, so we use the probability of it occurring up here, so we use 2.
2 was it, yes.
So the probability of it not occurring, we have to go use 0.
0.
And the probability of it not raining at all. Remember, point 3 is the probability of it raining, you know. So
Yes,
if it's
sir.
not raining at all, it has to be 0. Because this is 0 days. 0 here is 0 day. 1 here is 1 day. This is 2 days. So 7 through 0 is 1. 0.3 through 0 is 1. What is 0.7 to the 7th power?
41.03.
41 point
0.033 or 0.34.
0.7 raised to the.
I get 0.08.
Me get 0.082.
Oh, yeah, 0.0823.
Lord Jesus, 0.0823. Yes,
235,
sorry.
yeah. All right. So therefore, when we do this calculation, 1 times all of that is just going to be 0.08235. And then now we're going to calculate the probability of it just raining on 1 day. Because remember, those are the probabilities that not going to happen. So the probability now, the probability of it raining just for 1 day is going to be 7 choose 1. Remember, you know, the probability of it raining is 0.3. So it raining for 1 day is going to be 0.3 to the first. That means 0.7 is going to raise to the how much power?
6.
6. Very good to get that. 7 choose 1 is 7. 0.3 to the first power is 0.3. And 0.7 to the 6 now is going to be
0.11764.
11764. We're going to call it 765. Because
So both of them must always equal to 7.
right. Remember, 7 is a week, you know, is the probability of it raining within that week that we want to, we're interested to find out. So when we multiply that now by the 0.3 and the 7, we get 0.24. .706. So what I now have is going to be 1 minus 0.08235 plus 0.24786. And then now when I add up that to the 0.08235, I get 32.
0.32941.
Yes.
.67059.
Very good. So that's a probability of it raining at least 2 days. That's a probability of it raining at least 2 days. We don't have to remember now, you know, at least 2 days, you know, say it can rain for 2 days, it can rain for 3 days, it can rain for 4 days, 5 days, 6 days, 7 days. We know say it didn't rain for those. So what we need to do now, we know that the sum of the probabilities will equals to 1. So if we can calculate the probability of it not raining, we can subtract the probability of it not raining from the probability of it raining every day, which is 1. Remember, you know, that 1 is representing the probability of it raining every single day. True or false?
True.
Yeah, man. So what we need to do now, if we calculate the probability of it not raining none at all, and we subtract it from the probability of it raining every day, then we're going to get the probability of it raining for the at least 2 days, which is day 2, 3, 4, 5, 6, 7, those 6 days. Follow me?
Yes, sir.
All
Yes,
right.
sir.
All right. The other one says the probability of it less than 2 days. The third one says less than 2 days. How do we write that? X is less than that. Can I write less than or equal to? Let me hear you.
No, have to be less than.
Why?
So it's specifically say less than 2 days.
Very good. Very good. I have to do that because if it is less than or equal to, that means it would have equal to 2. Right? But it specifically said less than 2 days. So we have to, it particularly said less than 2 days. So we have to use X is less than 2 days. We specifically have to use X less than 2 days. No. The probability of that occurring is going to be what?
1 or 0?
1 and 0, good. The probability is going to be when X equals 0 plus the probability of it when X equals 1. Did we calculate the probability of it being 0 before?
The,
0 wouldn't
yes,
be 0
yes,
0.3082235.
yes.
And did we calculate the probability of it occurring at 1 already?
Yeah.
Yes, we did.
0.24786. Did we calculate the sum of that already?
Yes, we did.
Right here, so it's going to be 0.329. So the question took longer than that because I was using the opportunity to teach and to explain and to make connections with other areas that you're going to be using to work the stuff. So it means then that other questions that I will be sending off to you should be a little bit more easier than this. Make sense?
Yes, sir. You're sending
All right.
this.
I want you to look at this. I'm not doing anything else. I want you to look at it and see if I'm going to send this off to you. But I want you to look at it. We're talking about the binomial, the distribution here. We know what the binomial distribution is all about from pre-calculus. We are going to be applying it into our probability. We're applying it into our probability. So in the first part of the question, it says the probability of it being equal to 2. Of it raining for exactly 2 days. So therefore, raining for exactly 2 days, we know that the probability of it raining for 1 day is going to be 0.3. So that is going to be 0.3 raised to the second power. And we also have to find out the probability of it not raining at all. Now, if the probability of it raining for 1 day is 0.3, the probability of it not raining is going to be 0.7. Just think about it. It makes a lot of sense. If there is a probability of me passing that exam at 60%, the probability of me failing is going to be 40%. Hear this one out. So you're doing a multiple choice question and you rule out 2 of the answers. Matter of fact, you get a multiple choice question, ABC. What's the probability of you selecting the correct answer?
1 out of 4.
1 out of 4. Which is 0.25. 1 out of 4. 1 out of 4. Now, hear me out. If when you read the question, you see, you know, say, two of them answer you can't be the answer. 2 of the options can't be the answer. it is only, you know, say, A and D can't be the answer. So you know the answer is between C and D. What is the probability of you getting the question right?
1 out of 2.
Which is?
0.5.
Which is 50%.
Mm.
So you move the probability of you getting the question right from 0.25 to 0.5. You follow what I'm saying? So you have a greater chance of getting the question right because in their process of elimination, you eliminate those two answers. No, if you do another process of elimination and eliminate of the two answers, you eliminate one of them, you know, so you get the question right. It's the same thing with you right here. So the probability of something occurring is the same thing as 1 minus the probability of it not occurring. Does that make sense?
Yes, sir.
Mikey, you gone?
I'm here. Hello.
Right. So I'm saying the probability of something occurring is the same thing as 1 minus the probability of it not occurring. So this is what it is that we did for this one.
Oh, so it's basically, it would have been the same thing if you had the table written out on one side and then you carry it over to minus it from the one.
Same way.
Oh.
So just remember, the probability of something occurring is the same thing as 1 minus the probability of it not occurring. So I will now need to find out what is the probability of it not occurring right here. And it not occurring less than 2 is going to be 0 and 1. So I need to calculate the probability of it not occurring at 0 using the same formulation as we did up here. It not occurring, remember the probability of it raining is 0.3. So it not raining is going to be raised to the 0 power. That means the other one has to be raised to the 7th power. Why, sir? Because the sum of the probabilities must be equal to the overall power. We know this from the binomial expansion. We know this from the binomial expansion. All right. This is what I'm going to be doing. I'm not going to send this off to you just yet. What I'm going to do is I'm going to copy the question to this workout. We also did a binomial distribution question before this one on Tuesday. So I'm going to send both of them, and I'm going to generate 2 more questions on each, the binomial distribution and this other one here. So we can have those 2 to try on your own for me for next class. Oh, that sounds.
That sounds okay, sir.
All right, big up on yourself. Remember,
sir,
guys,
before you go, there was something else that you said we were gonna send from last week Thursday. When Asia and I were in class, the same one with the red and the black ball in the box.
You are correct. I have it right here. Hold on. You are correct. Hold on. Hold on there. No, that's not that one. Hold on. I have so many. I know that's true. I need to close out some of these documents. Hold on the pass because I don't want to go. The one you're talking about, pass?
With the probability 3?
Yeah, the one you pass?
Yeah, that one. Yeah.
All right. So, all right. So I'm going to put all of them on one page and send it off to you. Thanks for reminding me, pass, because I have it open on my system right here still. And I never remember to send it off. All right. So I'm going to send off the one for Tuesday, this one for Thursday, plus the one that we did in class today. So you're supposed to say 3 questions on it, plus I'm going to give you 2 additional questions to do on your own. That's okay?
Yes, sir. That's good.
All right, big up on yourself. Oh, before, guys, I recognize that the movements on Edico has stopped. That's all I'm going to say.
I'm not resume this weekend.
Okay, bless your heart. All right, we'll talk, guys. You did well. Later.
All right.
Cool.